Okay, so we're going to start with these problems here. All right, so I know we went over some of these in class, but we'll just go over them again. Okay, so for this particular problem, we're talking about people with O negative blood and trying to find the probability of selecting someone who's O negative. And so the probability for success is 0.06, which means our probability of failure will be 0.94. Okay, so just something to keep in mind. It says, if donors line up at random for a blood drive, how many do you expect to examine before you find someone who has O negative blood? So with this particular question, just off the top with no other information, this would be a geometric model. And so for that, our expected value would simply be 1 over our p-value, which is 1 over 0.06, which is approximately, I think it was 16.67, but let me make sure. Yes, 16.67 people. You also could say donors because it's understood that the people would be the donors. Okay, so then what's the probability that the first O negative donor found is one of the first 4 people in line? So this also would be geometric. And so the probability that X is equal to 4 is 0.94 to the third power times 0.06, because we would have 3 failures before we actually had 1 success. And so that value, when we type it in, is 0.0498. Also remember, you can type this in using the geometric PDF. Okay, and so it would be 0.06. Our X value would be 4. And notice you get the same thing. Okay, all right, moving right along. Okay, what's the probability that there are 4 O negative donors in a group? In a group of 50 donors standing in a line. So this would be a binomial model. So the N is 50, X is 4, and P is 0.06, Q is 0.94. And so we went through these particular problems in class, but I just want to kind of go over it for students who weren't available, who were absent. You can definitely speed through this part to skip to the pieces that we need. And so this would be 50, choose 4 times. Okay, so this will be a binomial PDF because there's an equal sign here. And so we set it up in the calculator. Now, granted, I'm using the 84, but you can most definitely use the Inspire. And I would practice using both just to make sure I'm comfortable with inputting my information into either calculator. Okay, and so I'm going to do a direct copy from the calculator. And so this was 0.1733. Okay. Yes, we would typically write our sentences for this information, but just for the interest of time, we're going through to make sure we know how to work the problems. Okay, so for our next set, this one, your N value is 100. Your X is 7. Your P and your Q still remain the same. Student asked me, why do we need the Q? We just note the Q for the formula part of it, just because remember, as I explained in class, sometimes with the multiple choice questions, they may want to know if the formula was plugged in correctly. So that's why we practice writing out the formula. No, you don't necessarily need to know how to type the formula into the calculator per se or work it out, but just knowing how to identify if the correct formula was indeed used. So that's why we practice writing it out. Okay, and so this value is 0.142. Okay. All right, so the next one says, what is the probability that 10 or fewer donors out of 87 are O negative? Okay, so we're trying to find, so right now we're dealing with 87. We're talking about 10 or fewer, and we know that the P and Q are remaining the same. So we said the probability that 10 or fewer. So X is no greater than 10. Okay, so that's important to understand. 10 or fewer, so 10 is our max. And so for this particular one, we're going to have to use the binomial CDF because we have an inequality symbol here. So as far as the formula goes, we'll just set it up like this because we'll start with our smallest value, which is 0, okay, because we have 0 donors. And then we'll just do our 3 dots to show that, yes, we added up everything in between all the way up to, uh-oh, I put 10. That should be 87. Sorry. Okay, this should say 87. All the way up to 87, choose 10. Oh, this should also say 87. This should say 77. Okay, so we have our binomial CDF. So it's going to be 87.06 and then 10. Hopefully you can see that. And so go to the calculator, binomial CDF, 87.06 and 10. And we get 0.985. Okay. All right, so if you have any questions, make sure you write them down in your notes and we'll continue right along. Okay, so it says, what's the probability that 4 or 5 of the donors out of a group of 63 are O negative? So remember, whenever we're doing probability and we have the word or, we're going to add. So this is going to look like the probability that X is equal to 4 plus, or X equals 5, which then becomes probability of X equals 4 plus the probability of X equals 5. So we're going to have to add together 2 of the binomial PDFs. And so you'll add up their values. So you're going to have the binomial, PDF of 63.064 plus binomial PDF of 63.06 and then 5. Okay, so I'm going to do the first one. So the binomial PDF, we have 63 trials, 0.06 is the success, probability of success. And so 4, that's going to be, and so I'm going to do 4 decimal places, 0.2005 plus, and so actually I'm just going to press second enter and change that to a 5. And I'm going to do 4 decimal places here too. Uh-oh, almost dropped the phone. So 1, 5, 1, 0. Always breaking these. And so when I go and I say this plus that, we get 0.3515. All right, the next question says, what's the probability that at least 1 out of 20 donors? So remember, probability of at least 1 was equal to, we had to do our complement. So 1 minus the probability that x is equal to 0. And so this becomes 1 minus the binomial PDF of, let's see, 20.06 and 0. So 1 minus, I'm going to do my distribution, 20. So this gives me 0.7099. Okay. Here we are with H. So it says, what's the probability that at least 6 of the donors out of 200 is O negative? So probability at least 6, so that means 6 is the minimum number. Now with this particular one, because we want to know the probability of basically 6 or higher, we have to kind of use the complement rule in a sense. So it's going to be 1 minus the probability, oh my God, I keep breaking my leg, that x is less than or equal to 5. Okay, x is less than or equal to 5, because we want to take out all of that probability to get us the rest. And so this would be 1 minus the binomial, CDF, excuse me, not PDF. And it's CDF because it's the inequality. Oh my goodness. Of, let's see, 200.06, and this time 5. So 1 minus second distribution. So 200.06, 5. And so that is 0.9823. Okay. And so suppose 20 donors come to the blood drive. What are the mean and standard deviation of the number of universal donors among them? Okay. All right, so mean and standard deviation, so that's expected value and standard deviation. So, oh my goodness. All right, so the expected value for this particular scenario would be n times p, so it would be 20 times 0.06, which is 1.2. And the standard deviation for that would be the square root of NPQ. And so that would be approximately 1.06 donors. Okay, so if you have any questions, make sure you write them down in your notes.